Hi everyone. Today we're gonna talk about how to name alkene and alkyne structure. But before start learning this subject, I recommend you to see our video that we talk about how to name alkane structure, and if you see it, you could understand and learn this video so better. So let's start how to name alkene and alkyne structure as easy as it's possible.
I bring a structure for you that you can't name it by a short educational video.
Well, let's check this structure out the end of this video that we can name it or we cannot.
Give me back.
No.
Give it back to me.
No.
Give those.
Let's do that. Alkene and alkynes naming are like alkane's method with some tiny difference. As we know, alkene have double bond in their structure and alkynes have triple bond in their structure. So the biggest difference between naming alkene and alkyne structure is this double bond. For example, when we wanna find our main chain, the double bond must be in our main chain. Or we have to start numbering the main chain from the way that it's nearer to double bond or triple bond. To understand it better, we compare alkane steps and alkene and alkyne steps. As we know, in alkene structure, in step 1, we choose and we find the longest number of carbon chain as our main chain. But in alkene and alkyne, we choose the longest number of carbon that the double bond or the triple bond be contained in that chain. Here, a question may come to you. That in a structure, if you find a way that we have the most number of carbon and the double bond or the triple bond doesn't exist on that chain, could we choose it as our main chain? The answer is just one word. No, we couldn't. For example, in this structure, if we start numbering and counting the straight way, we have 1, 2, 3, 4, 5, 6 and 7 carbon. But this way doesn't contain our double bond, so it couldn't be our main chain. The main chain is this way that start with a double bond, and we have 1, 2, 3, 4 and 5 carbon. As we see, this is our main chain even if we have lower number of carbon. So the priority is with the double bond, not the maximum number of carbon that doesn't exist the double bond. Okay, we understand the step 1. In step 2, we have the same method. As we see, we find the substituent group and name them, and we do it in alkene and alkynes. In step 3, in alkane, as we know, we start numbering from the way that is nearer to the substituent group. But in the alkene and alkyne, as I said, we have to start numbering from the way that it's nearer to double bond or the triple bond. For example, in this structure, we start numbering from this way because it is nearer to the double bond. But if we don't have any double bond, it's changed to this structure and we start numbering from the way that it's nearer to the substituent group because we don't have any double bond or triple bond. So to understand these different better, we show the steps in examples. We also have to consider one note that we didn't have it in alkane note. As we know, in here we have double bond and triple bond. So when we wanna write our main chain, we have to write the number of first carbon that attach to the double bond. So it's time to have some example. But before we start naming some structure, let's find out the name of the structure based on alkene and alkyne. We know that the name of C2H6 is ethane, but based on alkene, it changed to C2H4 and the name becomes ethene. The name of alkene are based on its name. For example, C2H4, the name is ethene. C3H6 is propene. C4H8 is butene. Or the name of hydrocarbon based on alkyne. For example, C2H2 is ethine. C3H4 is propyne. C4H6 is butane. That's it. Now we are ready to name some structure. Let's do that. Well, let us start with a simple structure. If you remember, we used this structure when we were talking about the difference between alkane and alkane in step 3, that we have to start numbering from the way that it is nearer to double bond, not the substituent group. Okay, let's naming steps by steps. In step 1, we have to find the longest carbon chain that contains the double bond. If you start numbering the straight way, we have 1, 2, 3, 4 and 5 carbon. But if you start from the up to down, we have 1, 2, 3, 4 and again 5 carbon. So you can choose both of them as your main chain. I choose the straight way as main carbon chain. And we know the name of 5 carbon based on alkene because we have a double bond is pentene. So step 1 is done. In step 2, we have to specify and identify the substituent group. That in here we have only 1 carbon and we know the name of 1 carbon based on alkyl is methyl. And this is the step 2. In step 3, as I said, we have to start numbering from the way that it is near to double bond, not the substituent group like alkane. If I start counting from left to right, it is 1, 2, 3, 4 and 5. And if you face the double bond in carbon number 3. But if you start numbering from right to left, we will face the first carbon that attached to double bond in carbon number 2, as you see it in here. So the right way for numbering is right to left because it is closer to double bond. Let's number that. 1, 2, 3, 4 and 5. So step 3 is done too. Now we can name our structure by helping the 4 nodes. As we know, we have to start naming with the substituent group. We have a methyl that it is attached to carbon number 4. So we will write 4, and as we remember, we have to put a dash between number and word for methyl, and then we have to write our main chain. As we see in note number 1, we have to specify the number of first carbon that attach to double bond or the triple bond. And in here, the first carbon that attached to double bond is carbon number 2. So we have to write the number of this carbon, and we will write 2-pentene. So it's done. Okay, in this structure, as we see, we have a double bond in here and it is alkene. As you remember, we use this structure, we want to show that the double bond must be in our main chain. For example, if you start numbering the straight way, we have 1, 2, 3, 4, 5, 6, and 7. But in this way, the double bond isn't contained in our main chain. So this way is a wrong main chain. So we have to find a way that the double bond is in that. If you start from this way, you have 1, 2, 3, 4, and 5 carbons. And if we number from this way, we have again 1, 2, 3, 4, and 5 carbons. So it doesn't matter that we choose which one of them as our main chain, because in both of them we have the same number. I choose this way as our main chain. As you see, we have 5 carbon, and the straight way we had 7 carbon, but we couldn't choose the straight way as our main chain because the double bond wasn't on that chain. It was a good structure for step 1. Find that we always have to put the double bond or the triple bond in our main chain, even if the number of our main chain is lower than the way that the double bond, the triple bond doesn't exist on that way. Okay, we know the name of 5 carbon based on alkene is empty. So step 1 is done. In step 2, we have to find the name of substituent group. In here we have 3 carbons that they're not in our main chain. And we know the name of 3 carbons based on alkyl is propyl. So step 2 is done too. In step 3, we have to start numbering from the way that is nearer to double bond. And it's obvious that if you start naming from up to left, it is nearer. So this carbon number 1, carbon number 2, 3, 4, and 5. Now it's time to name our structure. You know that we have to start naming on the substituent group. We have the propyl that is attached to carbon number 2 in our main chain. So we have to write 2 dash propyl, again dash. As note number 1, we have to write the number of first carbon that attached to double bond. That in here it is 1, and we write 1 dash the name of our main chain that in here comes. So the name of this structure is built. In this example, we see a triple bond in here, and we know the name of structure that have triple bond is based on alkyne. There is no difference between naming alkene and alkyne. The only difference is the name of main carbon chain. That's the name of main carbon chain of alkene is based on its name. It's a suffix of in, and the name of alkyne is based on its name suffix of -ine. For example, when the name of a main chain based of alkane is ethane, when it changed to alkene, the ethane changed to ethene, and when it changed to alkyne, the end of the name of ethane that's in here based on alkane is A and E changed to Y and E, and it will become ethyne. Okay, let's name this structure steps by steps. As you know, step 1, we have to find the longest carbon chain that the triple bond be on that chain. If you start numbering in a straight way, we have 1, 2, 3, 4, 5, and 6 carbon. But if you start numbering from here, that we have a C2, we have 1, 2, 3, 4, 5, 6, and 7. So if you start numbering from down to right, we have more number of carbon that the triple bond exists in this way. So the right way is this way, that we have 7 carbon. And we know the name of 7 carbon based on alkyne is heptine. So step 1 is done. In step 2, we have to find the name of substituent group. That in here we have carbon that we know the name of one carbon based on alkyl is methyl or methyl, and we have a Br in here. We know that the name of Br as functional group or substituent group is bromo. Okay, step 2 is done too. In step 3, we have to start numbering from the way that is nearer to triple bond. And if you start numbering from down here, we have 1, 2, 3, 4. In carbon number 5, we will face the triple bond. But if you start numbering from right to left, we'll face the triple bond in carbon number 2. So it is closer to triple bond, and the right way for numbering is right to left. Let's do it. 1, 2, 3, 4, 5, 6, and 7. So the steps are done. As we know, we have to start naming with the substituent group. But in here we have two substituent groups. That one of them is bromo and the other one is methyl. In note number 2, as we saw that in alkane we have to name the substituent group in alphabetical order. For example, bromo starts with B and methyl starts with M. So bromo is near to A in alphabetical order, and we have to start naming with bromo. The name will become 5-bromo because bromo attached to carbon number 5 in main chain, and then dash again 5 because methyl is attached to carbon number 5 too. 5-methyl again dash. As note number 1, we have to specify the number of first carbon that attached to triple bond, and the first carbon that attached to triple bond is carbon number 2 in main chain, and we'll write 2 dash the name of our main chain, that it is hepyne. So it's done. Well, we did 3 examples to get ready for naming this structure that you're supposed to do it in the beginning of this video. Let's do it. As you know, step 1, we have to find the longest carbon chain that contains the triple bond. If you start numbering in a straight way, we have 1, 2, 3, 4, 5, 6, 7, and 8 carbon. But if you start naming from the C2 down here, we have 1, 2, 3, 4, 5, 6, 7, 8, and 9 carbon. So from this way, we have more number of carbon, and the triple bond is existed in this way. So this is the right way for our main chain, and we know the name of 9 carbon based on alkyne is nonine. So step 1 is done. In step 2, we have to name the substituent group, and we know any kind of material that are not in our main chain are substituent group. So let's name them. We have a carbon in here in left, and we know the name of one carbon is methyl or methyl. Then when we go in a straight way, we face a C2, and we know the name of C2 based on alkyl is ethyl or ethyl. Then we see a bromo and fluoro on top of the bromo, and in the end we see 2 chloro that they are in the opposite side. Okay, step 2 is done too. In step 3, we have to number our main chain from the way that is nearer to triple bond. If you start naming from right to left, we'll face the first carbon that attached to triple bond in carbon number 5. But if you start from the C2 down from the left, we'll see the first carbon that attached to triple bond in carbon number 4. So the right way for numbering is left to right because it is closer to triple bond. Step 3 is done too. Now it's time to name our structure by helping from the notes. As we know, we have to start naming from the substituent group, and the priority is with the substituent group that is closer to A in alphabetical order. As we know, bromo starts with B and this is closer to A, so we have to write bromo in the first, and we know it sticks to carbon number 7, so we'll write 7-bromo. Then we have to write chloro that it is after than B. We have 2 chloro, and we know from the note when we have more than one substituent group that they have same name, we have to use the prefix di, tri, tetra, penta, and the other. So we have 2 chloro in here that both of them sticks to carbon number 8, and we have to write 8, 8 dash di chloro. Then we know that ethyl is closer to A and it sticks to carbon number 6, so we write 6-ethyl. After that we have to write fluoro that sticks to carbon number 7, and we'll write 7-fluoro, and at the end we have to write methyl that sticks to carbon number 3, so it will become 3-methyl, and in the end we have to write the name of our main carbon chain. When we want to name our main carbon chain based on alkene and alkyne, we have to write the first number of carbon that attached to triple bond or the double bond. And in here, the first carbon that attached to triple bond is carbon number 4. So we have to write 4- and the name of our main chain that it is nonine. So it's name so easy.
You cheated!
No, it was easy.
I will come back and give you a question that I'm sure you can solve it.
Do your best. Good luck. Stay with us and be your best.